Good morning, ladies and gentlemen. My name is Bambang Sugiyono Agus Purwono. I'm a lecturer in State Politeknik of Malang, Indonesia. The first, I would like to thank to God and Dr. Rudra as GAO of Bioliquid Wild and the organizing committee of this international conference. My paper title is Producing the Railway Sleeper Using the Plastic Waste as the Raw Material. I am the first author, and we also join research together research with Dr. Narulita from Jakarta, State Politeknik of Jakarta, and Dr. Is Mariam, and Mr. Masroni, Mr. Heru Purnomo, and Dr. Ruel T. Bongansiso from Philippine Normal University. This paper will be presented in International Conference on 7 Go Green Summit, organized by Bioliquid Wild India. The themes unfolding the concept of green technology to achieve zero emission 14 until 15 of October. The outline will start from research background, literature study, research method, result and discussion, conclusion, and references. The introduction. The research background is number one is the plastic waste in Indonesia, around 20,000 tons of plastic to produce per day. Number two is at least 20% of this plastic waste, which is believed to end up in the river and coastal water. Number three, developing the recycling industry and toward fulfilling its promise to cut waste. Number four, the Indonesian nation plastic waste collection capacity to reach the target of 4.29 million tons by 2030. Number five, how to switch the plastic waste become productive product. The problem is number of plastic waste is very large. Number two, how to reduce plastic waste. Number three, how to produce the plastic waste to become marketable products. Switching the plastic waste to become railway sleeper. And number five, how to test, to realize, and to socialize the plastic railway sleeper. There are two research objectives. Number one is how to design and to produce the plastic railway sleeper. Number two, how to describe, to explain, and to analyze the railway sleeper using plastic waste as raw material. Data waste reviews according to the island. We have 5 big islands: Sumatra, Java, Bali, Kalimantan, and Papua. And there are produced the waste. Sumatra is 8.7 million ton per year. Java is the biggest one, 21.2 million ton per year. Bali, 1.3, and Kalimantan 2.3, and Papua 5.0 million tons per year. Data source of type of waste. Number one is source household is about 22.4 tons per year, million tons per year, and this is about percentage 58%. Plastic 5.4 million tons per year is about 14%. Paper, the quantity of the waste of the paper is 3.6 million ton per year, is about 9%. And the other ones, 2.3, wood 1.4, glasses is 0.7, rubber and leather is 0.7, clothes is about 0.7, metal is 0.7, and sand 0.5 million tons per year, and the total is 38.5 million tons per year. The limitation of this research is, number one, we use the appropriate technology. So this technology is small capacity, and the other one, this is the uncontrollable variable is government regulation. There are two former researchers. Number one is Rehan and his friend. The method is descriptive methods. The description is there is an eye contact or distance between the machinist and the car's driver. Railway sleeper type are woods, metal, and concrete. This is the research. And number two, the research in the year of 2018-16, the researcher is Dwi Pospasari. The method is quantitative approach. The description is the specification of concrete railway sleeper is suitable according to AREMA standard. No cracking, and the tensile strength is 569.601 kilonewton. This is our research variable is, number one, we would like to observe about the cracking propagation, and the screenshot of the plastic waste railway sleeper. And number three is we observe about water absorption in railway sleeper. And number four, we observe about the fiber in the plastic railway sleeper. And number five is what about the flexibility of the railway sleeper? The later study, the definition, plastic are organic chemical compound of high molecular weight that have a structure resulting from the repeated linking together of small molecules called monomers. The resulting long chains molecules are polymers. Number two, there are two types of plastic. Number one is thermosetting material and thermoplastic material. The type of thermoplastic is polyethylenes, high density polyethylenes, low density polyethylenes, and polypropylenes and polystyrenes and polyvinyl chloride or PVC. The characteristic of plastic. Number one is lightweight and specific gravity, about 1.1 till 1.5 kilogram per decimeter cubic. Number two, higher corrosion resistance. Number three, good electrical resistance. Number four, low thermal conductivity, variety of optical properties, formability, and ease of application, one-stop operation. Number seven, the surface finish is. Number eight, comparatively low cost. And the last, number one, low energy content. This is the equipment, the plastic extrusion machine with plasticizing component in evidence. The product is, we can see tubes and pipe, then sheet and film and structure part. There are feed hopper and plastic pellets, heater, shaping die, turning screw, barrel, molten plastic, and extruded. This is the component of railway. You can see in this picture. This is the connection between the metal railway and the railway sleeper. The research method, our research method apply a qualitative approach. This is the flowchart of our research, start from the research till the documentation. The research and discussion. This is the step in producing the plastic waste railway sleeper. Start with collect the plastic waste from the ponds, and after that we separate between thermosetting type and thermoplastic type. And step number three is we wash and dry the plastic waste and then cut up the plastic waste become a granular grain, and then we forms the plastic waste, the granular of plastic waste, especially in thermoplastic plastic, is using the extrusion machine or appropriate extrusion machine. Step number 6 is transport the plastic waste railway sleeper to the location. Number 7, step 7 is testing the plastic waste and plastic railway sleeper. We test using the bending testing, and then the tensile stress testing. Then we try to presentation and socialize about our observation about the plastic waste railway sleeper, and then we try to continuous improve our research. This is the step in producing a plastic waste railway sleeper. We try to look for the plastic waste in the big market, outside of the big market, and then we spare it between thermoplastic plastic and thermosetting plastic, and then we cut, and then we cut up, become a granular, and then we process we form the plastic wicks in the simple extrusion machine. This is the products, the railway, plastic railway sleeper. Then we testing. This is the bending testing material. Then we install the plastic railway sleeper in the real railway station. Then we experience is we test in the critical of the railway road. This is until 6 times. Then we socialize and present this research to in national seminar and try to introduce to international conference. This is the type of the railway sleeper. This is concrete railway sleeper, then the metal railway sleeper, and then this the wood railway sleeper. This is the bridge, wood railway bridge. The conclusion of this research paper is the research result reveal there are, I think, there are no cracking, and the lowest shrinkage, and then the lowest water absorption, and small fiber in the plastic railway sleeper, and the last, the sleeper flexible is good enough. The references and my biodata, my biography, then thank you for your attention. Then you can see our presentation in my YouTube. You can searching Bambang SAP Sierra Alpha Papa. Thank you for your attention.